we're looking at a relationship between acceleration and mass. So the procedure is quite simple. We need to set up the experiment as seen in the picture. So here we are looking at a car. Then we have the sensor 1, sensor 2, and we have the mass at the other end being tied to the car. So set up the experiment as seen in the picture. Okay. Note down the net mass of the toy car. So since we are trying to establish a relationship between acceleration and mass, the mass of what? The mass of the car, not the one which is pulling it. That is the force. This is the source of the force. This is nothing to do with the mass of the car. This is fixed. This is not to be changed. Force is constant for all the cases. The one which we are dealing with is the net mass of the toy car. That is the object under observation. That is the one which is going to get accelerated. Actually, all of this is going to get accelerated, but the point is we are reading that. We are reading the value of the movement of this car. Okay. So we are looking at the net mass of the toy car. Then we need to drop the mass, that is, let it accelerate. Observe the velocity and acceleration attained by the toy car, that is, to read the values from the screen. Then we'll change the net mass of the toy car. Please make a note, not this. This is not to be touched. The toy car mass is changed. That is, I'll just place few more weights on this. It's not seen over here, but it's seen when we do the experiment. Okay, so I made arrangements wherein I'm going to change the mass of the car. For the same fixed mass m1, that is force, this is your force, remember. How is that this car is going to accelerate when we put extra weight? What do you think happens? You have a car wherein a single person is sitting. We have a car wherein 10 persons are sitting. The same car. What happens? Can it move with the same speed? No, right? For the same amount of petrol, so for the same amount of efficiency, something has to reduce. That is, the speed will reduce. So that's what we are going to see, right? So please have a look at this experiment. You will understand things better. So clearly what happened? Let's see the data. Observation. The net force will remain the same, that is 0.6 Newton. That is, the mass m1 will remain fixed. That would be the force that is acting on the car. Now, the net mass of the vehicle is 80, 30 and 10. So I'm showing it in a reduced manner. The final velocity for the first, second and third cases are, final velocity of the first one is 0.86 and this is 0.98. This is 1.340. 395, right? 40 is good enough. Acceleration is 1.07. Please see here. This is your acceleration. This is your final velocity. This is 1.39. The last one is again 1.40, right? If I approximate this is 39 and this is 40. A small variation, but still a variation. So what is happening? When we are reducing the mass, right? Again, whenever you get any kind of data, you need to learn to read it, understand it, interpret it, derive things from that. So when I moved from 80 to 30, acceleration increased from 1.07 to 1.39. Further reduction, further increase. So what can we tell? The conclusion is this: when an unbalanced external force acts on an object, its velocity changes, that it accelerates. That's true. The acceleration is inversely proportional to the mass m for a fixed force. That is, if I increase the mass, right, if something has to be pulled by you guys, forget about car, think about physical pulling. Okay, not a good diagram, but yeah, you guys can understand. If I have to pull something heavy, right, say, let me, that would be better now. Yeah, if I have to pull something heavy, let's say 1 Newton, that's kind of very less. 101 Newton, that's a lot. Yeah, but okay, 10 kg, that's good enough. Or if I have to pull something that is not that heavy with the same force, obviously what happens? This will accelerate and this won't accelerate to that extent. It's as simple as that, right? So in the first case, since it's very heavy, like over here, or a bit heavy, doesn't matter, there is reduction in acceleration because you guys have known it, seen it. It's not something which is new. It's something that you understand and experience in day-to-day life. So as and when things get heavier, it's tough to accelerate for the same amount of force. See, the force is fixed. You can tell, sir, can't we just accelerate? Accelerator means we are putting a force. More acceleration means more force. But we are fixing the force, remember. Is it not? So the acceleration is reduced. Right? Again, I would like you guys to pause. Think over what is that you need to write. You must write these 2 points. There's no other option. Conclusion has to be written. Everything else in between is something that you guys can draw or write in any language possible, anyhow possible. Doesn't matter. Drawing like this will help. You call this as A1, this is A2, then this is M1, this is M2. Then you tell M1 is greater than M2. Then over here you tell A2, A1 is lesser than A2. This makes sense, right? It's easy to compare. Looking at the diagram, you understand that, okay, we have the same force. The acceleration is different. So that's how you can represent things. So you need not draw much. So such simple diagram is more than enough. Okay.